Hello and welcome students. This is lecture number 20 of indefinite integration. So today we will start with a type, and the type is integral square root of ax square plus bx plus c dx. That is, we will learn how to integrate a function which will look like this. If an integrand, you all know the function which you are integrating, it is known as integrand. So we are going to learn, if we see an integrand which look like this, how we will integrate. For example, if I have to integrate square root of x square minus 12x plus 3 dx. So see, this is square root of ax square. What is a here? 1 plus bx. B is negative 12 plus c dx. This is square root of ax square plus bx plus c dx. What are a, b and c? I can write here, where a, b and c are real constants. They are real constants. So this is example. You can call this as an example for this type. This is an example. This question can be considered as an example. There is one more name for this type, and that is the name is, yes, you all guessed it correctly. The name is integral root quadratic dx. So students, you must have understood that what we are doing today, it is in continuation with what you had done earlier. If you remember, then we had done 1 upon quadratic. If you remember, we have done type 1 upon quadratic dx. That is 1 upon, we have integrated 1 upon ax square plus bx plus c dx. Then when we learned, and when did we do this? We did this when we learned the first set of theories. Then we did integral 1 upon root quadratic. We did integration. We did the type integral 1 upon root quadratic. That is 1 upon square root of ax square plus bx plus c dx. And when did we learn this type? This type we learned when we did the set 2 theories. Now those who do not understand what are set 1 and set 2 theories, so for them I will suggest that you will have to go to previous lectures and find it out. In last lecture, in lecture number 18, I have taught set 3 theories, and after set 3 theories we are doing root of quadratic. So let us begin with this. Set 3 theories. What are set 3 theories? The one that we did in the last lecture was, sorry, in lecture number 19, what we did was set 3 theories. And set 3 theories were, it was square root of x square plus a square dx square root of x square minus a square dx, square root of a square minus x square dx. We had done, this is set 3 theory. Set 1 and set 2 theory will also have 3 in each, but what form they are in, that you will have to see by referring to the previous lecture. So I suggest you watch the previous lectures. Okay, so here we have the type 1 upon, we have the type root quadratic, that is square root of ax square plus bx plus c dx. Now we will write the method. Let us write the method. Surprisingly, the method is exactly what you had written for 1 upon quadratic and 1 upon root quadratic. The method which you had written for 1 upon quadratic and 1 upon root quadratic, it is the same method. So what was the step 1, dear? Step 1 was make the coefficient of x square equal to 1. What was step 1? Step 1 was make the coefficient of x square equal to 1. Then what was step 2? Step 2 was find out the proper last term once you have made the x square coefficient equal to 1. And for that, what you will do, you will take a common. Like here you have a, so you will take a common. So the moment you take a common, suppose from here, if I take a common inside the square root, if I take a common, I'll get x square plus b over ax plus c over a. This is how I will get. Okay, so this is first step, that you will find out, you will make the coefficient of x square equal to 1. Then what is second step? Second step is find the proper last term. Find the proper last term. Last term in order to get a perfect square, involving the variable. Now I'll make you understand what is this. See students, when you have made the coefficient of x square equal to 1, now what you have here is 3 terms you see. This is first term, this is middle term, and this one is last term. But these 3 terms are not making a perfect square. They are not making a perfect square. In order to get a perfect square, I will find out the proper last term for these 2 terms. Like I will consider this as the first term. This is my first term. This is my middle term. And for these 2 terms, I will find out a proper last term so that this, this, and the last term which I will find, those 3 will get me the perfect square involving the variable x. Okay, and for that the formula is, what is the formula? Yes, correctly said, very well said. So here what you thought was perfect. See, using the formula, perfect square involving the variable, using the formula, and what is the formula? The formula is last term is equal to half multiplied to coefficient of x, half multiplied to coefficient of x the whole square. This is the formula for last term. Okay. Once you have found out the last term, now step 3. Step 3 is add and subtract. Add and subtract the last term to get a perfect square involving the variable and a constant square. Surprisingly, my dear students, these first 3 steps are exactly the same that we had done for 1 upon quadratic. 1 upon quadratic. It is the same that we had written. There also everything you did was same, because do not forget that whatever your working is, the working is only for the quadratic. So whether the quadratic is in denominator and numerator being 1, or the quadratic is inside the square root in the denominator with the numerator being 1, or the quadratic is the way here it is, that is in the numerator inside the square root, it hardly matters. These all are different structures. Now what happens, if you work on this quadratic ax square plus bx plus c, finally you end up with that corresponding structure, and hence that corresponding theory we will use. So here, which theory did we use? Here we used the set 1 theories. For such problem we used set 1 theories. 1 upon x square plus a square dx, 1 upon x square minus a square dx, 1 upon a square minus x square dx for this. And for this, if you remember, we had used sec 2 theories. What were sec 2 theories? It was 1 upon root of x square plus a square dx, 1 upon root of x square minus a square dx, 1 upon square root of a square minus x square dx. And this time, which theory we will use? We will use set 3 theories. Why? Because this time we have the quadratic inside the square root in numerator, and hence set 3 theories. Okay, very important ideas. So the last step here, now we will write the 4th step. So step 4, I write step 4, and after step 3, step 4 is apply a proper result from set 3 theories. Set 3 theories. I hope you all have understood. When I will solve problem for you, you will understand much better. So let's begin with a question. This question is, when I will begin with it, you will find that this question converts into root of quadratic. So here I have two, inside the square root I've got 2 linear factors of x multiplied. So here what will you get? You will get 7x minus x square. I multiply this x first with the bracket. So when I multiply x with the bracket, I get 7x minus x square. Then I multiply negative 3 with the bracket, I get negative 21 plus 3x and dx. So finally I get here negative x square plus 10x, 7x plus 3x is 10x, minus 21 dx. So this is root quadratic. What is this type? This integral is integral root quadratic. Now you know the method. The method is, first I will make the coefficient of x square equal to 1. So for that I shall take negative sign common. Negative is common here. So negative 1 or negative sign, whatever you say. So x square, I'll get x square positive, but then 10x will become negative and 21 will remain positive dx. Okay. After this, but remember one thing, students, that when you take a negative sign out from the quadratic, that negative sign should not be taken outside the square root. It will remain inside the square root. Okay, if you take it outside the square root, this negative sign should never be brought outside the square root. Okay, if it was some number, suppose here I had, for example, if I had 7, so it is just a number. So 7 can be brought outside. So you can write root 7. So the next step, root 7 can be written outside, and then here you will get only this quadratic. But if you have a negative sign, that negative sign should not be brought outside. It will remain inside. So the first step is over, that I made x square coefficient 1. The second step is I will use the proper formula and find out the last term. So last term formula was, see, the finding out last term, the formula calculation and all, it need not be part of the solution. You can do it elsewhere. So last term, as you all know, coefficient of x, half of the coefficient of x. So coefficient of x is -10. Half of that is divide by 2, and then you square it. So it is -5 square, which is 25. So the proper last term is 25. What is next step? I will add and subtract this last term in order to get the perfect square involving variables. So I have x square minus 10x plus 25, and since I added 25, I need to subtract 25 plus 21 and dx. Okay, this is what it is, dx. So the next step is, so here I will get I equals to integral square root and negative sign. Now having found the last term, proper last term, now these three terms will get you a perfect square. Now you get a perfect square involving that x. And what is that perfect square? It is x minus 5 the whole square. And here you have negative 24 plus 21, which is -4 and dx. So the next step you write is integral square root of negative x minus 5 square minus 4 is -2 square and dx. Now I take this negative sign inside. So when I take negative inside, see what it will become. When I take negative, now this negative sign which was kept outside, it will go inside. You can take it in. So it will become constant square. See, as of now, without this negative sign, what you notice is you have variable square minus constant square. Okay, you have variable square minus constant square. But remember, students, the scene will exactly be reversed when this minus sign will come into effect, and it will become constant square minus variable square. It will become constant square minus variable square. And this is set 3 theory. We have already done this. What theory are we going to use here? We are going to use the theory which was 1 upon constant square minus variable square. If you remember, we had done 1 upon a square minus x square dx. What it was? X by 2, that is variable by 2, the square root as it is, root of a square minus x square plus a square by 2 and sine inverse of x over a plus c. So here what we have here, so we have here I equals to, we apply that, so x by 2, that is variable by 2, the variable here is x minus 5, okay, which is an linear algebraic expression. I repeat, it is a linear algebraic expression. though it is not x, but it is still allowed. So here I will write x minus 5 by 2 and then square root as it is, multiply to this square root as it is, which is 2 square minus x minus 5 square plus a square by 2, which is 2 square upon 2, and sine inverse of x by a, that is variable upon constant, x minus 5 upon 2, the bracket is complete, plus c. Now you know, students, what will this be? So here you will get I equals to x minus 5 over 2, and as you know, inside the square root you have this, which is this, which is this, which is this, and so finally what it is? It is x minus 5 upon 2, and I can write this one here, you know. Remember, what you see here inside the square root, it is nothing but this, which is nothing but this whole thing, which is nothing but this thing, which is nothing but this thing. Okay, these all are same things. So what I would do, I would write the most compact form. So I write here negative x square plus 10x minus 21 plus 2 square by 2 is 2, and sine inverse of x minus 5 by 2 plus c. This is my final answer. You can watch this whole thing once again and do this problem once more for you. Solving it is important. Question number 11 and 12. These two questions you will take for your practice. I have also written the answer. You can check that answers here for root quadratic type of integral problems. The answers are too lengthy. Okay, but then it is what it is. We just can't speak more about it. So students, now we go for the next type, and the next type here is, recently which type we did root quadratic. So the next type here is linear into root quadratic, that is px plus q linear into root of quadratic, px plus q multiplied to ax square plus bx plus c dx. Okay, now something that I have written here, it is a new type, but it is not a new idea that you all follow, that though we are solving a new type of integral problem, but then definitely it is not a new idea. Why it is not a new idea? Because if you remember, earlier we had done 1 upon quadratic. I will explain this to you in short. So when we had done 1 upon ax square plus bx plus c, what was the next type immediately after this? What was the next type? The next type was, we wrote in the numerator px plus q, and we called this as linear upon quadratic. If you remember, we had done this type also. Okay. Similarly, when we did the type, 1 upon root quadratic, after having done this type, if you remember, what was the immediate next type? Same thing, we multiplied px plus q, that is a linear algebraic expression, in numerator. This was linear upon root quadratic was our next type, and we had done this. Okay, now this time what is happening? The type that we did, students, the type which we have done is root quadratic. Which type have we done? We have done root quadratic. This was the type, root quadratic. So after this, which type will be the next one? as usual, we will multiply in the numerator px plus q. Now when you multiply px plus q in the numerator here with this, you will get something which is looking like this one. You have px plus q linear into root quadratic. So the other name for this will be, the other name is or linear into root of quadratic ax square plus bx plus c dx. This is the type. And you know where a, b and c are real constants, where a, b and c are real constants. They are real constants. Okay. Let us write the method for linear into root quadratic. The method for linear into root quadratic will be same as the method for linear upon quadratic and linear upon root quadratic. I repeat this once again. The method for linear into root quadratic will be same as the method for linear upon quadratic and linear upon root quadratic, with a slight change, and that change will come in, I guess in step 3. So let's see what was step 1. Step 1 is same as the step 1 for those two type, and it was adjust the derivative. adjust the derivative Adjust the derivative means manipulate and try to repeat the derivative. Okay, adjust the derivative of quadratic. Adjust the derivative of quadratic. By writing quadratic, I mean ax square plus bx plus c. Adjust the derivative of quadratic in place of linear. In place of linear expression. By linear, I mean px plus q. Linear expression. Step 2. Step 2 is, there you had written split the denominator. After you had adjusted the derivative of the quadratic in place of linear, you see that derivative of quadratic is visible in the numerator. Then what you do is you split the denominator for the derivative of quadratic in earlier those type, in earlier two types. Which two types? Where you had linear upon quadratic and linear upon root quadratic. But here you do not have denominator in quadratic. Here what you have the root quadratic in numerator. So here there will be no separation as such. What it will be, I will write. See, after you had adjusted the derivative of quadratic in place of linear, the next step is multiply, or you can say split the square root of quadratic, split square root of quadratic for the derivative, for the derivative of ax square plus bx plus c. Split the square root of ax square plus bx plus c for the derivative of ax square plus bx plus c by multiplying inside the bracket, by multiplying inside the bracket. Now what does this mean? This will be clear to you when I will solve the problem. Okay, just wait, this will be clear to you when I will solve the problem. We will split, like see, you have, suppose you have linear into root quadratic. Okay, you have linear into root quadratic, and here you adjusted the derivative of quadratic here. Okay, so when you are doing some adjustments, you will definitely have some constant, plus or minus constant. So what you will do here, you see that derivative of this is here. So you want this thing to be with the derivative. So what you will do, you will split it, you will split this whole thing. How will you split this whole thing? You will split this whole thing by multiplying. You will multiply with this and with this. That is what I have written. Split the square root of x square plus bx plus c for the derivative. Why do you split? Because you want this derivative to be with the quadratic, because it is nothing but derivative of quadratic. So you will split it. And how do you do that? You do it by multiplication instead. And you remember, you do here by multiplying inside the bracket. And you remember, when this thing was in the denominator, you split. When this thing was in the denominator, what you had done, you remember, you split. If it is in the denominator, you split. Like this thing, I will take you back. When that thing was in the denominator, here what I had written, when it was in the denominator, once again our aim was to write this derivative part with this. So what we did, we split here, like we split this upon the denominator plus this upon the denominator. But here we don't have it in the denominator, instead we have this in the numerator, so we would multiply. I hope you have understood this. Okay, if you have not understood, do not worry. When we will solve the problem, you understand it better way. So split the denominator, I'm sorry, split the square root of x square plus bx plus c for the derivative of quadratic by multiplying inside the bracket. And then we have step 3. Step 3 is use the result integral f of x raised to n into f dash x dx, and the theory and the theory and the theories from set 3 and the theories from set 3 to integrate the given function, given integral. Okay, so here we will take a problem for the practice. Let's solve a problem. Let's solve a problem on same type which we just learned, that is linear into root quadratic. So integral, we have sec square x into square root of sec square x into square root of tan square x plus tan x minus 7 dx. Oh, this one is not linear into root quadratic, it is simply root quadratic. But since I have written it, I will give you the solution of this up to a stage, and after that you can take it to its end. So since I have written, let me go ahead with it. See students, here the integrand that you see is sec square x into square root of tan square x plus tan x minus 7. You know what I will do? First of all, I will try to convert this into one of the type. And which type do I find this is closest to? listen to the question. The question is, which type do I find this is closest to? If I'm not able to put it into a type, that is, if I'm not able to transform, I will never be able to integrate. Because remember, integration is nothing but application of a result. If you cannot apply a result, you cannot integrate. So I would like to convert this into a type. Okay, now what do you think, which type this one is very close to? Definitely it is close to root of quadratic. It is close to root of quadratic. Why? Because I see here inside a square root, I see here square, then I see here same thing without square having power 1. See, I have tan x square, then I have tan h power 1, then I have a constant. So I understand that there is a bleak chance of this being getting converted into this type, and then I will start working on that. Now what I notice is inside the square root, I have terms of tan, but outside I have got a sec square x. So you know what? I now see here, if I put if I put tan x as t, if I substitute tan x as t, then after derivative, which is must, every time you substitute something as t, you differentiate that, okay? Because then the differential has to be different. If it is in x, it is dx. So when the integral will come in t, the differential has to be dt. So differentiation is must. When I put tan x as t, differentiating, I will get sec square x dx. And now I go ahead. After having thought this much, I will go ahead. So see here, I write, put tan x equals to t. I put tan x as t, then I differentiate with respect to x. So I get d by dx of tan x is sec square x, and d by dx of t is dt by dx. I multiply dx here, so I get sec square x dx equals to dt. Now as I had told you students, sec square x dx, I will write dt. So the new integral that you write is I equals to integral, this whole part is dt, this whole part is dt, and inside the square root you have, see, square root of tan square x. What is tan x t? So t square plus tan x t minus 7, t square plus t minus 7, t square plus t minus 7. And what is sec square x dx equals to? It is dt. Sec square x dx is dt. So square root of tan square x plus tan x minus 7, square root of t square plus t minus 7, and this is dt. Now this is root quadratic. You can easily solve this. This is root quadratic. You know the method. Here coefficient of t square is anyways 1. So you will directly start by finding the proper last term. The proper last term. T coefficient is 1. You will get half of that. What is half of 1? Half of 1 is 1 by 2. Then you square it, 1 by 4. You will add 1 by 4, subtract 1 by 4, and then you will go for variable square, constant square inside the square root, and then you use one of the proper result from set 3 theory. Okay, I hope you will do this. Let me take another problem for linear into root quadratic. So we solve question number 9 here, which is linear into root quadratic. I and x square root of 5 minus 4x minus x squared dx. This is, yes, this is linear into root of quadratic. Linear into root of quadratic. Now students, you know what happens? Many a times what happens is, when students see this negative of x square, when they see this negative of x square, they start with making x square positive 1, because that is one of the step. You remember, we make the coefficient of x square positive 1 plus 1. That is okay. We make the coefficient of, if you remember when I had done that, step 1, make the coefficient of x square positive 1, x square equal to 1, positive 1. Okay, we had done this. But remember, you do so when you have root quadratic. You don't do it when you have linear into root quadratic. Right now it is not simply root quadratic. If I had only this much, please try to understand, if this x was not there, then I would definitely do it. I will make x square positive 1 and all that. Then I will go on that line. But right now what I have? Right now I have linear into root quadratic. So my first step will be I adjust the derivative of quadratic. By quadratic, I mean this expression. I adjust the derivative of quadratic in place of linear. So what is derivative of quadratic here? Derivative of quadratic is minus 2x minus 4. If you differentiate 5 minus 4x minus x square, you get minus 2x minus 4. So see what I do. I write here 1 upon minus 2, so that this becomes minus 2x. See, I divided by minus 2 so that I can multiply minus 2 here. Okay, so minus 2x, so 5 minus 4x minus x square dx. So I got minus 2x. I want minus 4. Derivative of quadratic is minus 2x minus 4. Now I want minus 4. So I will write minus 1 by 2 and minus 2x minus 4. See, I wrote minus 4. So I will write plus 4. I subtract 4, add 4. And then here I have 5 minus 4x minus x square dx. Now what I will do, students, I will go for the next step. What was next step? Next step is check. What is this part here inside the bracket? The bracket which you have, this part here is a derivative of quadratic. It is derivative of quadratic. So you achieved your goal. What goal did you achieve? You achieved your goal in getting the derivative of quadratic in place of linear. Where you had linear, now you see the derivative of quadratic. So what will be next step? You will split for the derivative of quadratic by multiplying. You will multiply this whole thing, this whole square root, with this part which is derivative, and also with 4. Okay, I hope you all are understanding. So next step is, see what I will do. The next step I will write is, see, I will write the next step as, minus 1 upon 2 and how we have a plus b and outside c. So how we write? Don't we write ac plus bc, like we multiply c with a and c with b? Same thing we are going to do. So see, this minus 2x minus 4 I write in a bracket, and plus 4 is another term, and outside I have square root of 5 minus 4x minus x square dx. Now I multiply this inside, so minus 1 by 2, and then see this multiply. When I multiply, I get minus 2x minus 4 into square root of, see this I multiply with the derivative here, so 5 minus 4x minus x square plus 4 into square root of 5 minus 4x minus x square dx. Okay, then next step is I will split the, I will now write separate integration. Now let me write separate integration. So when I do that, see what do I get. Let me write the separate integration. So here I have I equals to minus 1 by 2 and integral, okay, minus 1 by 2, then I write a bracket, minus 1 by 2. Okay, or I will do one thing, I'll write both together. I will write separate integral, at the same time I will multiply minus 1 by 2. So minus 1 by 2 integral minus 2x minus 4 times 5 minus 4x minus x square dx. Okay, and when this minus half multiplies the second integral, I'll get minus 2. I'll get minus 2 times because 2 to the 4 and negative sign, minus 2 times integral square root of 5 minus 4x minus x squared dx. Okay, now here what happens is this one you will be able to integrate in the very next step. You can integrate this in the very next step. How? It is because you notice derivative of this quadratic is here. So this is the type. What type? I will write here. See, I write here. This is now the result. I will write using f dash x, using f of x raised to n into f dash x dx equals to f of x raised to n plus 1 upon n plus 1 plus c. This result we are going to use. And how will that be used? I'll show you in the next slide. So here, see, we will have therefore I equals to, you have negative 1 by 2, negative 1 by 2 integral 5 minus 4x minus x square raised to half, okay, into minus 2x minus 4 dx. What I did, this one, the square root I wrote, it as raised to half into minus 2x minus 4 dx, the first integral, minus 2, and this one, students, please note that this thing I write it as I1. I write this as I1. Why? Because I understand that here I will have to work separately. Okay, it is not going to get integrated in the very next step. So here I write minus 2 I1, and this is my equation number 1. Okay, so or maybe not this as equation number 1, just leave it as I1. What I do next is now I integrate. So here I have minus 1 by 2, and you apply the result for the first one. You apply the result for the first one. That is, you integrate this because the result is applicable. It is f of x raised to n plus 1 upon n plus 1. So I have 5 minus 4x minus x square raised to half plus 1, half plus 1 upon half plus 1 plus c dash. Why I write c dash? Because you integrated. If you have integrated, you will have to add a constant of integration. Okay, if I was able to integrate all of these integrals, I would have added just one constant at the end. Okay, but then since I noticed that I'm integrating only one part and the other part is still to be integrated, which when I will integrate, I will add c1. So with c1 and c dash, then finally I will write c minus 2 I1. Okay, so here what happens is I get minus 1 by 2. So here this is 3 by 2. So this 2, half plus 1 is 3 by 2. So 2 and 2 will cancel. So I will get minus 1 by 3. And this is 5 minus 4x minus x square raised to 3 by 2 plus c dash minus 2I1. This is my equation number 1. And what I do next, students, now I will go for I1. I will write, consider I1. What is I1? I1 is integral square root of 5 minus 4x minus x squared dx. And here now you start with the method of root quadratic. See, here you start with the method of root quadratic, and in this here you started with the method of linear into root quadratic. Okay, so now once I got root quadratic, what is first step? I will make the coefficient of x square. I will make the coefficient of x square equal to positive 1. See, this is getting very lengthy. I will make the coefficient of x square equal to positive 1. So let me begin with it. I have here I1 equals to integral root of, I take a negative sign out, so I get x square positive plus 4x minus 5 and dx. What is next step? So I get I1 equals to, now I find out the proper last term. So the last term here is 4, because coefficient of x is 4. You divide it by 2, you get 2. When you square that 2, you get 4. The last term formula is half the coefficient of x, the whole square. So negative, I get here x square plus 4x plus 4 minus 4, and this minus 5 was already there. So I get I1 equals to integral square root of negative, the first three terms get me the perfect square, x plus 2 the whole square, minus 9, this gets me minus 9, which I write it as minus 3 square and dx. Now this outside negative sign outside the bracket will come into effect, and it will get me square root of, it will get me exactly reverse of what I see here. I see here variable square minus constant square. It will become constant square minus variable square. That is 3 square minus x plus 2 the whole square. Okay, and what is it now, students? It is the set 3 theory. That is square root of a square minus x square. So I will get here I1. Okay, the final answer will be I1 equals to, the answer for I1 equals to x by 2, that is x plus 2 upon 2, and the square root as it is. This whole square root you write as it is, which is 3 square minus x plus 2 the whole square plus a square by 2, that is 3 square by 2 sine inverse of x plus 2 by 3, x plus 2 upon 3 plus c1. Okay, I'm writing c1 because this is I1. Now what will happen, students? Next, you know, this square, the content of the square root here, this thing is nothing but this thing, which is this thing, which is this thing. Yeah, it is same, they all are same. You only wrote it in order to make it look like a result, where you can apply a result, which is this thing, and finally this thing. So what I will write here, in order to make it look simplified, I will write this one. So here I1 equals to, I will get here I1 equals to, I don't want to move to next page because that will unnecessary trouble you. So here I get here I1 equals to x plus 2 upon 2 square root of 5 minus 4x minus x square plus 9 by 2 sine inverse x plus 3 upon, I'm sorry, x plus 2 upon 3, x plus 2 upon 3 plus c1. This is the I1. This is what? This is finally I1 you got. What will you do next, students? This I1 you would now substitute, you will substitute I1 here. Okay, and then you will multiply minus 2. Okay, this I1 you substitute here in equation 1. You multiply that with minus 2. So that minus 2 will cancel this 2, and it will be minus 2 c1. Okay, that minus 2 c1 with c dash will become c, and you will get your final answer. No doubt, students, this is very lengthy problem, but remember one thing, this problem teaches us a lot. It teaches us a lot about integration. I hope you all have understood. This is not the final answer. I told you the final answer you will get when you substitute I1 in 1. Okay. I hope you all have followed. If you haven't followed, then you can do one thing. You can see this whole solution once again, and please practice this kind of problems. from whichever book, whichever notes you are referring. It is that type. This I'm sure this type you will get in those books also. Thank you. The next video we will go ahead and have some more concepts on integration and some problems. Thank you.